Today we will discuss physical chemistry chapter that is called electrochemistry. We will not discuss in very much details, but yes, I will cover up all the concepts in a form of my input, which is as short as I can, or a very long video. Okay, so this chapter is electrochemistry, which is your physical chemistry, one of the very important chapter where you will get at least numericals. So let's not waste any time and let's start. At the beginning of the chapter, you just need to know two words. That is, one is an electrochemical cell and second is the electrolytic cell. So if I talk about electrochemical cell, I'm just writing in very brief electrochemical cell. So if I'm talking about an electrochemical cell, then electrochemical cell means this cell is what we use in a battery. So this is exactly what we use in our appliances like your watches, those handmade and those hanging watches also. So all this will convert your chemical energy of the battery into the electrical energy. So this will convert your chemical energy to electrical energy, right? Chemical energy to electrical energy. This is electrochemical cell. On the other hand, we have a electrolytic cell also. Cell electrolytic cell, which is also called voltmeter. This can be told very important. Huh? This A is very important because if you miss out this Z, it becomes a voltmeter, which is not in chemistry but in physics. So this is electrolytic cell, which is just going to do the opposite. If you give it electrical energy, it will get converted to chemical energy. But we will study more about electrochemical cell and not about electrolytic cells. So this will get converted into chemical energy. Okay, this is just a basic introduction of the chapter. You need not know much about this. Next, very important concept in this chapter is few terminologies. First, let me explain you. When you are doing this electrochemical cell, you have seen that in a battery, that is the cell that you are using, it's not a battery, actually we call it a cell. So the cell that we use, it has two ends. One end is a positive end and one end is a negative end. So the end that is a positive end is a particular electrode and the end that is a negative end is another electrode. Now what is exactly meant by an electrode? Definitions I'm just saying, I'm not writing because these are not needed. This is the terminologies you will see from your book, it is mentioned. If I talk about electrode, the first and the foremost term is electrode. So what is an electrode? An electrode is basically the two rods that are placed, two rods or two substances that are placed in a type of beaker or container, whatever you take, and this is exactly where the process will occur. The process of transfer of energy, that is transfer of electrons, will occur in this place at both the electrons. So how many electrons are there? Two electrons will be there, right? In a particular electrochemical cell, there are always two electrodes in it. Two electrodes, one is the positive electrode, one is the negative electrode. So how will you remember it? So under electrode you have two type of electrode. One is a positive electrode, one is the negative electrode. Positive electrode will be called as positive. Now you tell me who loves positive? Who loves positive? Always negative loves positive, right? Positive will never love positive. There are exceptions, it's different. Negative will always be loved by positive. So opposite. So if this is a positive electrode, then this must be attracted by a negative substance. That means this will be attracted by an anion and this will be attracted by a cation, right? So cation has the words letter C, this has the letter A, so this will be your anode, clear? And this will be your cathode. Remember like this. Remember C will go with C, A will go with A. So cation will go to cathode, anion will go to anode. Clear? Anode therefore becomes positive and cation being positive charge will go to negative charge, that is negatively charged electrode, so that will become the cathode. Done? This is the first thing, electrode. Next, as you can understand that anion will go there and it will form something. So there must be an exchange of electrons because wherever a reaction is happening, there is an exchange of electrons only. In chemistry, whatever reactions are happening, this is formed due to change in electrons only, right? Electrons are being changed from here and there. The number of electrons are being changed. A bond is being formed. Different types of bonds are being formed. So electron is the one who is getting changed from here to there and there to here, right? So what happens exactly, you tell me, even if you know that anion means negative charge. So let me write one anion. Suppose it is m to the power n minus, which is an anion. So what will happen? It will lose one electron, right? It will lose n number of electrons, rather not one electron, it will lose n number of electrons, right? So it will lose this electron because it has excess of electrons. So it will lose the electron to form this M. Correct. If it has n minus charge and if it is losing the n electrons, then it will go back to its M state. Similarly, if M gains n number of electron, then it will become Mn minus again. Right? So that is what I have written exactly like this only. Mn minus n of E. This is what exactly I have written. Right? Now if it is a cation, then what will happen? So suppose the cation is M n to n plus. Then this will take up some number of electron, there is n number of electron, and then it will form a metal. Now as you have read in class 11 redox reaction chapter that if electrons are being gained, this is a gain of electron, so this is a gain of electron, so this I will call it as a reduction, right? This I will call it as a reduction, and this is a loss of electron, so this I will call it as a oxidation. This is the easiest way to remember actually. Which side what will happen? This is loss of electron, this is gain of electron. So this is reduction, this is oxidation. This you have to know that loss of electron is called oxidation, gain of electron is called reduction. Done? So now you see this anion is going where? Anion will always go to anode. So which electrode will oxidation happen? That means where will the oxidation happen? Which electrode? So it will happen always at anode. Clear? So no need to remember like this, remember like this way. Then you can remember it for a longer time. If you just try to memorize it, ultimately you will forget in the exam. Clear? So always remember that if the question is asked in fill in the blanks, not in details they will ask you. Oxidizing electrode, anode. Reducing electrode, cathode. Clear? So where will metals be formed? Because metals are mostly cations. Metals cannot form anion, like very readily it does not, actually it does not also. So metals will always be reduced at cathode. So at cathode you will get the metals deposited. Okay, the metals deposited you will get it cathode. But again, don't take it that all metals will be deposited at cathode only. If there are two metals in a cell, then one will be at anode, one will be at cathode. So please do not take it like that all the metals will be deposited at cathode only. If there are two metals cell, then one will go to anode, one will go to cathode. That is different, that you all know already. Clear? Okay, so I am repeating again. If there is a loss of electron, that means it is oxidation. If it is a gain of electron, it is reduction. Reduction always takes place at cathode. Anode always oxidizing electrode. This oxidation takes place at anode. Clear? Okay, so the first term electrode is clear. The second term, as I have already told you that there is a change of electron, then the electrons cannot move through air, because air is not a conductor of electricity. So air will not allow electrons to flow through it. Then how should I allow the electrons to flow through it? By using a medium, and that medium is called electrolyte. That medium is called electrolyte. Clear? So electrolyte is the medium through which I will be sending my electrons from one electrode to another electrode. The medium that I need to keep in between will be my electrolyte. Clear? So definitions please read on the book, because I don't have that much time. They can write the definitions here. Okay. So electrolyte understood. Electrolyte will be the substance which has to be there so that the electron transfer can happen between the two electrodes. Okay. 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 Next, suppose I am drawing one diagram now. See, diagram is very important. This is one and this is one. Okay, so here I am placing one rod. Here I am placing one rod. Okay, here I am placing another rod. Two rods have been placed. Okay, acha. Now you see, these are two different. This entire setup is called an electrochemical cell. Entire setup is an electrochemical cell. Entire setup is an electrochemical cell. Specifically, it is a voltaic cell. This is an electrochemical cell, right? Entire setup will be electrochemical cell, not the separate. The entire setup will be an electrochemical cell. That is the full thing. I am just drawing this. This is the full thing. This full thing is an electrochemical cell, because people think that only this much electrochemical cell. No, the entire thing is electrochemical cell. Now if I take only this much, then this is a half cell. What is this called? Half cell. Okay, so if I ask you what is a half cell, then the two components that make up an electrochemical cell, each of those components will call it as a half cell. Clear? Now that half cell can be of two types, as you can understand. It can be an oxidation half cell or it can be a reduction half cell. Understood why? Either it can be an oxidation half cell or it can be a reduction half cell. Understood? Because one will be the cathode, one will be anode. So one will have the oxidizing power, one will have the reducing power. Clear? Now as you can see that both of them are separated by some gap. Both of them are separated by some gap. Right? Here is electrolyte. Electrolytes are here. Here is some electrolyte. Here is also some electrolyte. Right? So this substance will be called as electrolyte. Now you tell me that I will make the connection from here using a battery or whatever I have. So I will make the connection from here. But is the circuit complete? You have read in physics that current does not flow until the circuit is complete. Right? Current will not flow until the circuit is complete. Right? So how to complete this entire circuit, because there is a gap in between and that gap will not allow the electron to flow from this half cell to that half cell. And if it is not flowing, then my process of electrolysis will never happen. So how do I ensure that the entire circuit is complete? The entire circuit can be ensured by using a salt bridge. By using what? By using a salt bridge. So what exactly is a salt bridge? A salt bridge is basically a small tube like connection from this to this thing. Clear? It will be a tube, huh? The space is not there, so I am not showing. So this will be called as a salt bridge. What will be called it as? Salt bridge. So this salt bridge's major function is to ensure the circuit is complete. The circuit is complete and electrons or ions can flow from one half cell to another half cell. Clear? So please remember that if I tell you salt bridge function, because they ask you often, salt bridge can be asked, because many of you don't know what is a salt bridge. So what is a salt bridge? A salt bridge is a connection between two half cells. So what is the function of salt bridge? To complete the circuit. Okay, to complete the circuit. But how does it complete the circuit? To complete the circuit by allowing ions to flow from one half cell to the other. Right? Clear? So salt bridge's first function is to complete the circuit by allowing ions to flow from one half cell to the other. The second is to maintain electrical neutrality of the cell. Okay, to maintain electrical neutrality of the cell. Okay, the entire electrochemical cell must be electrically neutral. So to maintain the electrical neutrality of the cell. Clear? So what does it mean? Electrical neutral cell means what? Here suppose in this electrolyte, electrolyte is there. So if here by chance positive charge comes up, that means something excess of positive charge might be. So from this salt bridge, the negative charges will come here, so that this does not become any excess charged. Any charge does not get in excess. So neutral, this will be also neutral, entire thing will get neutral. Clear? So I can also write instead of this. So if there is a positive charge excess over here, then negative charge will come. Suppose here there is a negative charge excess, then positive charge will come from here and make it neutral. Clear? So instead of this line, I can also say I should say that it will maintain the electrical neutrality of the solution present in both the half cells, rather not the cell. The entire cell ultimately will be neutral, but it is basically, I should write this only, to maintain the electrical neutrality solution present in half cell, means electrolyte present in half cell. Okay, clear? So that means when either half cell gets excess positive charge or excess negative charge, the opposite ions will come to counter it. Next question that can come in your mind is, which substances we will use in the salt bridge? So generally we use KCl solution, Other than KCl, you can use KNO3 solution also. But generally, we give KCl solution. If you want, we can use KNO3 solutions also. We can use K2SO4 also. An example, just remember it, no problem. But which substances should be used? So please remember that the substances used should not react with the electrode or electrolyte. Clear? The substances that we have used, it should not react with the electrolyte or the electrode. Then what we want, we never get. Electrical interactivity will be this. So please remember that the substances we use should not react with the electrode or the electrolyte. Clear? Never issue. This is the prime condition. Clear? Half cell is clear? Understood? Till here you have understood the concept, basic concept? Very good. Achha, next, how to represent a cell. So to represent a cell, basically you tell me, always left side will write oxidation. Left side always we will write oxidation. Right side always we will write reduction. Always left side oxidation, right side reduction. Clear? So first we are writing the oxidation. So in oxidation, loss of electrons. So M to Mn plus. M to Mn plus. This is the first thing, because loss of electron, oxidation. Loss of electron, oxidation. So M to Mn plus. Now you remember that whenever we are writing a metal, we will use solid. Metal is in solid state, so metal will be always in solid. So we write bracket S. But whenever it is becoming an ion, any type of ion, then it will become an aqueous state. So we have to mention AQ, or if concentration is mentioned, we write the concentration in bracket. Okay. So as I have already told, please remember left side oxidation. So right side will become reduction. Okay. So left side oxidation. So M bracket solid plus, sorry, not plus. Okay. Then 1 slash no. This is one mistake you all make. You put like this, Mn plus Aq. Many of you do this, but it is not the correct one. Why did you place a slash in between the transfer? No. The slash will be placed only after a half cell is complete. Please remember, the slash that we are putting will be put only after one half cell is complete. Clear? Clear? So M solid slash M N plus aqueous, then N plus slash MS. Okay, this is reduction, this is oxidation. One is oxidation, other one is reduction. Tell me clear? Tell me clear? Clear? So basically, slashes what we will put, this I will combine, I am not combined yet. First half cell is the oxidation half cell, second half cell is the reduction half cell. So first you are writing the metal or whatever. First you are supposing the oxidation you are writing in the left side is the first oxidation, metal written slash metal N plus. Okay, but most of you also write like this, that is Mn plus then slash. This will become double slash. Okay, I think I said slash, that is my mistake, sorry. It will be double slash, not one slash. Okay, so one slash will be in between them and another slash I am telling you that later on. So first you write a metal, then you give one slash, then you give Mn plus aqueous, then the second half cell, that is Mn plus aqueous slash Ms. Done. Now you are going to combine both. How you are going to combine? This you are going to just put beside it. If I put like this, then though it does not make any sense. Then how to know where to put? Then what will I do? That's why I told you that you will put double slash. What will you do? You will put double slash. Clear? So this double slash represents salt bridge. This double slash represents salt bridge. And this entire equation represents, entire setup, entire syntax represents an electrochemical cell where these are the metals involved. Okay. Now in some questions you will find that there are given concentration. So in place of AQ there will be some value written. So that value will be the concentration of that ion. Okay, metal concentration will never be given, only Mn plus will be given, because you know for writing equilibrium constant we never use the metals. We have done in class 11. If there is a concentration mentioned, then you will write the equation like this. It will be given in the question usually. It will become M slash N plus slash something X molar, it will be given. Then M N plus, this will be separate, different, huh? Not same. Then this will be Y molar. Then it will be MS. Clear? So this is going to be my equation. Here, this is the concentration of this ion and this is the concentration of this ion. So when you are writing the equation for equilibrium constant, you have to use the given data from here. Okay? Clear? Okay. Okay. Now let us take up an examples. Just we need to understand that what exactly is happening. Okay. Let us take up a short, very short question. Nothing is there. Suppose the cell reaction is given as zinc 2 plus aqueous double slash Cu solid Cu2 plus aqueous to Cu solid. Okay. Okay. First question I'll ask you is, what is the change of electron? Change of electron. What is the change of electron? Means how many electrons are changed over here? How many electrons are changed over here? Then you will say it's very easy. Only 2 electrons are changed over here. Absolutely correct. 2 electrons are changed over here. This will be called as N. Huh? N. So N value will be required. So N means number of change of electron. It is called as N. We will represent it as N. Okay. Next question is, what is the cell reaction? Next question is cell reaction. They will ask you what is the cell reaction. Then how will you write the cell reaction? It's very easy to write the cell reaction. Cell reaction লেখার জন্যে first thing you will do is you write the first substance zinc, then you go with the second ion, this ion, then you write the first ion, then you write the second metal. Clear? This solid aqueous you can write. This is the entire cell reaction. Clear? Okay. Do not write copper plus zinc, please. Huh? Start from left side only, then go to right side. So first metal, ion, ion, metal. Clear? This is the entire cell reaction. Okay. Now suppose here it was not mentioned as AQ. Let us assume that here it is something else. I am writing a value there. So let us assume that it is not AQ. Let us write over here. Let us take a value is given 0.01 molar. This is 0.1 molar. Okay. Now you tell me how to find out the equilibrium constant. Equilibrium constant, that is Kc. How to find out the equilibrium constant? That is Kc. So remember in class 11 we have done, to find out the Kc you need to take up the right side. Always remember, this is very easy to remember also. Right side upon left side. The right side upon left side. Concentration of the products divided by concentration of the reactants. Concentration of product divided by concentration of reactant. Right side by left side. One thing you have learnt in class 11, that metals are not considered while writing Kc, because their concentration is considered to be 1, including water also. Water is also considered to be 1, the concentration, and metals we will not consider because that is also considered to be 1. So which ions we will consider? Only the ionic part. So this will become Zn 2 plus concentration divided by concentration of Cu2 plus. So what is the Zn 2 plus concentration? 0.01. What is the concentration of this? 0.1. Clear? So this will become 1 by 10. Okay. Now unit will not be there because this case it will be cancelled. Okay. Another thing, unit is also very important. Concentration unit is written as mole per liter. Okay. Mole per liter. So please check if there is any square cubic, then like that we have to write the unit. Here there is no unit because same unit will be getting cancelled out. Okay. Understood? How to find out this type of answers from one given question. This can come in short, like 2 marker questions in the section B. Okay, another question let us take up. This will be a little bit tricky. So this is Cr3 plus 0.01 molar. Then it will form, let us take lead 2 plus aqueous lead, so aqueous not 0.1 molar lead, sorry. Okay, same question. Question number 1, tell me how many electrons are changed. N equals to how much? How many electrons are changed? I'm writing N equal to number of electron change. So what is going to be the number of electron change? Here I cannot say, I cannot directly say, and only 3 electrons are changed. Why? Because charge is different. Charge দেখো CR এর মাথায় charge 3 আর PP এর মাথায় charge 2. So charges are different. So দেখে I cannot say that the number of electron change is 3 or 2. Then what will be the common between 3 and 2? 6. So the change in number of electron will be 6. Okay? The common will be 6. How will you find out? Find out by balancing the equation. That I am writing the equation, then we will get to know. Cell reaction. The cell reaction will make it clear. So as I already told you, write down Cr first, then write down the second ion, lead 2 plus aqueous state only. Then it will write the second ion, that is Cr3 plus aqueous state plus lead solid. Done. Now it is C, copper, chromium 3 plus, lead 2 plus, lead. Now charge, total charge by ion electron method, if you have done in class 11 redox reaction balancing, charge on both sides has to be same. Charge on this side 3, charge on this side 2, not same. So we have to change. How will you change? This is 3 plus charge. So let us take it as this is 3 and this is 2, right? So if I make it, this one, can I make it as 3? Then this will become 3 into 2, 6 plus, and this I will get as 2. This will become 2 into 3 plus, done. So 3Pb2 plus, this will be just 3, this will become as 2, done. So now see, 1 chromium loses 3 electrons, then 2 chromium will lose 6 electrons. Clear? Clear? 2 chromium will lose 6 electrons, 1 chromium will lose how many electrons? 3 electrons, as visible from here. Done? Understood? The balancing is also needs to be done like this. The charge on both the side has to be balanced. Very simple what I am saying. দুদিকে charge has to be same. Charge balance করার জন্য 2 আর 3 এর মধ্যে the commonest number is 6. That's why multiplied with 3 into 2 and 2 into 3. Done. Now from the cell reaction understood that 1 chromium loses 3 electrons, so 2 chromium will lose 6 electrons. So number of electron change will be 6, not 3 or 2. Please, okay. Acha, next, which question what we did there? Acha, Kc, that is equilibrium constant. So equilibrium constant, how will you find out? Equilibrium constant Kc. So that Kc value will be equal to, tell me, right side upon left side. That I have already told you, right side upon left side. So what is the right side? Cr3 plus. Then left side lead 2 plus. So this will become 0.01 by 0.1. So answer will be 1 by 10. Same question that we did previously, right? This is the same value that we did yesterday. This is wrong. Clear? Mistakes that we make in the exam. Wrong. This is wrong. Why it is wrong? According to the law of mass action, class 11, little bit you have to remember over here. According to law of mass action, you have learned that to write equilibrium constant, you have to mention the power of the that is the coefficient. The coefficient will be in the power. The coefficient in the reaction will be to raised to that power, right? So coefficient is here 3. Have you mentioned the 3 over here? No. Then you will not get marks. Clear? So whenever you are writing equilibrium constant, please make sure that if it is a balanced equation with any other number than 1, please write the coefficient as power. Otherwise your answer will be coming wrong. Okay? Okay, understood? What is the mistake you have done? Answer will come 1 by 10 only. That's not a point. But that is a coincidence. Coincidentally, the answer came 1 by 10. That is not the point, but this is wrong. Okay, so please remember this mistake that you are doing it here but not in ISC. So what will be the correct answer? You are going to write CR 3 plus then square divided by lead 2 plus cube. Done. So CR 3 plus was given as 0.01 square divided by lead 1 is 0.1 cube. So this answer will come ultimately 1 upon 10. But if you remember, the answer will be liter per mole. How did I write the liter per mole? Please, unit if you miss out, it's very unfair to lose a marks out there. Unit. Special focus on unit. Clear? See, square upon cube. The square will cut off. So only one unit will remain. It is mole per liter in denominator. So liter will come up, mole will go down. That's liter per mole. Not mole per liter, liter per mole, because the unit is like that. Okay. Unit, I hope you can calculate it from here itself. That's not a very big deal for you to calculate the unit. That's why I'm not telling you to remember the unit also. Just calculate it from the given one. Clear? Okay, this is the basic part done. Now we are moving on to the next topic, that is electrode potential. Achha. Whenever we are doing the electrolysis, we are completing the circuit. So moment we are completing the circuit, there must be a potential developed across both the electrodes. So the potential developed across the anode or the cathode will be called as electrode potential of that particular cathode, of that particular electrode. Clear? So what is electrode potential? Please read the definition from the book. I am writing the term somewhere, because it's not possible for me to write. So electrode potential. So what is electrode potential? Electrode potential is basically the potential developed on the electrode due to oxidation or reduction. If it is oxidation, then oxidation potential. If it is reduction, then reduction potential. Clear? So you remember the definition, you will read from the book. Electrode potential, the potential developed on an electrode, or the potential developed across an electrode due to loss or gain of electrons. Clear? 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 Okay. Now you see. Suppose this is one of my, I am taking one electrode, not both the electrode. I am taking one electrode. Let us take that this is an electrode and this is made up of M metal. Okay. Suppose I have a solution around this is my electrolyte. Okay. And this electrolyte has Mn plus ions. Okay. So now this Mn plus ions will come and collide. This Mn plus ion will come and collide with the metal. Now there are three conditions that can happen over here. What is that? First condition, Mn plus becomes M. Second condition, M becomes Mn plus. Our third condition is no change. These two are very known to you, because moment Mn plus becomes M, it gains some electrons. So this is going to develop my reduction potential. This is going to give my oxidation potential. Correct? Mn plus to M, this will either give me the reduction potential, this will give me the oxidation potential, right? So from here I will get my reduction. I am writing reduction, okay, reduction, and this is my oxidation, right? So from here I will get oxidation potential difference. I am writing oxidation potential only because I cannot write that thing now. Oxidation potential, and here I will get the reduction potential, correct? But what about the third case? What is happening? That there is no change. So one term you need to remember from here, that when there is no change, that means the electrode that you have used, that is called a null electrode. No work. Clear? And we will not get a potential because there is no electron loss. So if there is no electron loss, then where we will get the potential from? No potential seen. No potential seen. Clear? And the electrode that you have used will be called as a null electrode. Only know the terminology. No such question will be asked from here. Okay. So Mn plus to M will give you reduction potential. M to Mn plus will give you oxidation potential. If there is nothing happening, then that is null electrode simply. Okay. Tell me, clear? Okay. Now you will find out that throughout the chapter we will use this term electrode potential. Now suppose in the question it is given electrode potential will be written as E cell. It will be given like this, E cell. But E cell is different. Let me first tell you about the E cathode and E anode. So if I write E cathode like this, I will write E cathode. Then this means electrode potential of the cathode. If I write E anode, that means it means the electrode potential of the anode. Clear? Now if I write a value, then suppose I write 0.76 volt. Suppose here I write 1.34 volt. Right? Now you see, what will you interfere from here? Not interfere, sorry, wrong English. Infer. What will you infer from here? Cathode's potential is this. But what type of potential? That I have not mentioned in the question, right? I have not mentioned in the question whether it is a reduction potential or whether it is oxidation potential. No, I did not mention whether it is a oxidation potential or it is a reduction potential. So as I haven't mentioned, then what will you take? Always remember that when nothing is mentioned in the question, always by default take standard reduction potential. Not standard, ignore the word standard, that we will tell you a bit later. So always you will take reduction potential. So I am writing over here, by default take reduction potential. Clear? So always remember that by default you will take reduction potential, nothing else you will take. No oxidation potentials, please. By default, always you will take reduction potential if nothing is mentioned in the question. So suppose I have given E cathode as this or E anode as this. Okay. So from here you have to find out the electrode potential of the cell. Electrode potential of the cell. This is particularly half cell electrode potential. This is the standard electrode potential of the half cell. Rather, we will give a dot over here. So I am now giving the dot. See, I have written dot. So this dot indicates what? Standard conditions. Standard conditions are there. The standard condition means 298 Kelvin, 1 mole per liter and 1 atm pressure. 1 atm pressure, 1 mole per liter is 1 molar and 298 Kelvin is a physical chemistry condition. So this is called standard potential. So whatever you are saying, just add the word standard. Standard conditions. Clear? So this will be called SRP. We will call it as SRP. SRP. Done. And this will be called as SOP. Standard oxidation potential. This is oxidation potential only because anode will give oxidation potential. Cathode will give reduction potential. So standard reduction potential, standard oxidation potential. SRP and SOP. Clear? So this happens under standard conditions. What are the standard conditions? Though it will not be as, but might be by chance it is up 298 Kelvin, 1 molar and 1 atm pressure. This is my condition for standard reduction potential and standard oxidation potential. Okay. Now if this way it is given, then their confusion can arise that whether to take reduction or oxidation, but you have to take reduction. Another way of giving is basically they can give you also in this way. E0 Mn plus 2M, okay, equal to 0.76 volt, and they can give you E0 M to Mn plus 1.34 volt. Clear? So this you can see and this you can see. If this is one cell only, please do not take it as some other cell. So if this is one cell, then this will be the cathode, this will be the anode. So please check it out that which one is the cathode, which one is the anode. A little bit later on I will come to this because you might be a little bit confused that what are you writing, because you are writing the opposite thing and you are giving different values. Just now I will contradict my statement because I will say that these are same values. This should be the same values, but you can see that I am writing two different values. So you might question me that what am I writing? I am telling something, I am writing something. Moment I give an example, it will be very clear to you. So I am not writing it right now, I am just erasing it. So this can be written in this way. I am just telling you. If you cannot understand, no problem. Just take an example, you will easily understand it. I am giving you the guarantee. Okay. So E0 cathode and E0 anode will be written as that. Now how to write the E0 cell? That is very important. E0 cell. Because question will be needing this value. E0 cell. They will ask you for the potential of the cell. So what potential am I finding out? SRP only I am finding out. So I am finding out standard reduction potential, right? I am finding out what? I am finding out the standard reduction potential of the cell. I am finding out the standard reduction potential of the cell only. Correct? So again, you have to ensure that both the values are in SRP state only. Like this is basically in SOP state. But that you have to see from the question whether it is given in SOP state or it is given in SRP state. That moment you do some questions you will understand. So E0 cell always has to be in E0 cathode minus E0 anode. Clear? E0 cathode minus E0 anode. Okay. Please remember this very important formula. E0 cell is always equal to E0 cathode minus E0 anode. Cathode minus anode. Now your question will be how to know that one is a cathode and what is the anode. Question will be how to know which one is the cathode, which one is the anode. To know that, you have to know the electrochemical series. Memorization I'm not talking about, but a basic rough idea you have to remember. Generally they give you very common elements only, using copper, lead, zinc, aluminium, magnesium, lithium, these questions. Okay, so lithium is at the very top, aluminium will come a little bit next, zinc will come a little bit after that, copper is always below hydrogen, and lead is above hydrogen. So these much small things are there which you should remember. Clear? Aluminium, first is lithium, then aluminium, then a little bit later zinc. No, not a little bit later. Immediately after aluminium is zinc, then lead, then hydrogen, then copper. Which are the common things that they generally give. So what you have to remember from here? From here, you have to just remember that who is above who and who is just below whom. The common elements you remember. And using this, you can easily understand who is the cathode and who is the anode. Achha. Formula is clear to you. No doubt regarding the formula. Now let us quickly see some examples. Because if you see the examples, you will find that you can understand the concept. Okay. We were doing some questions over here only. Suppose let us pick up this question itself. No, this is chromium will not be given. Suppose let's take this question. Okay. So I am just copying this slide. We will take up the same question. So I am just copying this slide only. Just a minute. Okay. So I am just erasing this. Okay. This was my question previously given. I have taken the reaction has been written down. Now you tell me how to know that which one is the cathode, which one is the anode. As I have told you that how you identify using the electrochemical series. As I have already told you that copper is below hydrogen and zinc is above hydrogen, much above hydrogen. Okay, so zinc being above hydrogen, what it will do, and copper being lower than hydrogen, what it will do. Okay, in the question the values will be given. You have to just use the values. Okay, so I am giving the values in the question. Given in the question is E0 Zn 2 plus 2 Zn equals to minus 0.76 volt. This will be given to you in the question. So what you will do is you will just copy that from the question. Okay, and next is given is E0 copper, right? So E0 copper 2 plus 2 copper, copper 2 plus 2 copper will be given as 0.34 volt. Okay, this is given the question to you. Now the first and the foremost thing that we will check, as I have already told you, by default, this is very important. By default, take reduction potential. So that means you have to check which case, you have to check whether it is written in this format or not. E0, I'm writing, no problem. Whether it is written in this format or not. What is the format you will check? E0 mn plus 2m. This format you will check for. Okay, because this is reduction. So if it is written, if the question যে ভ্যালুটা দেওয়া, the question যে ভ্যালুটা দেওয়া আছে, whether it is following this format, then okay, I proceed with this formula. If it is not following this format, I will change it first. Okay, so see, let us see. Following this format, mn plus then m, mn plus then m. So whatever given data is correct data, I can just write it from there, no problem with me. Okay, acha. So let us find out E0 cell. So how will you calculate E0 cell? That is E0 cathode minus E0 anode. So as I have already told you that which one is cathode and which one is anode. Oh, I have not told you. Okay, fine. Tell me. Please remember. This is electrochemical series. Electrochemical series going below, top to bottom. This is top to bottom. SRP increases. What increases? SRP increases. SRP is standard reduction potential. So standard reduction potential increases as you go down the EC series. So as you go down the electrochemical series, your SRP will increase. SRP will increase means the value will also increase. That means toppermost is minus, then it will become plus. That way it is increasing. Okay. Now, what will happen if it is increasing? Always remember, no need to use your brain over here. Remember, whoever is above will be the cathode. Sorry, whoever is above will be the anode. Whoever is below is the cathode. Simple thing. Clear? Simple thing. Whoever is top will be anode. Whoever is below will be the cathode. Logic is there behind this, but we will not remember the logic right now because your exams are coming here. Okay, fine. So whoever will be below will be the cathode, whoever will be above will be the anode. Simple thing, no logic to be required over here. Okay. So below if you go, then what will become? Cathode. That is reducing power increases. So below if you go, reducing power increases. So top to bottom SRP increases, reducing power also increases. That has to happen. Okay, so top to bottom reducing power increases, SRP increases, reducing power increases, oxidizing power toppermost, and that is why the group 1 metals are at the top, because they are good oxidizing agent. Okay, clear? So now you tell me who is above? Zinc is above, copper is lower. So who will be the anode? Zinc will be the anode. Who will be the cathode? Copper will be the cathode. So copper cathode. From here you cannot understand. You can see from here you cannot understand who is cathode, who is anode, because both are given in this format, and this will become anode. Clear? So whoever is above will be the anode, whoever is below will be the cathode. So copper being the cathode will be 0.34 minus 0.76 volt. Total it will come is 1.10 volt, I think. 06. So clear? So 1.10 volt. Now one thing also you can understand from here. Suppose you did not do all this. You did this one. Suppose you did minus 0.76 minus 0.34. So your answer would have come minus 1.10 volt. Now you tell me, using a battery, using a cell, can you ever develop negative potential? No. Using a cell, you can never develop a negative potential. Right? Okay, please don't drag in physics over here. I'm not talking about physics. Okay. So you cannot develop a negative potential using a battery, using a cell. So you should get to know that you have found out the wrong value. So then what will you do? You will just interchange. That means if this E cell comes in negative, that means you have used wrong cathode and anode. Interchange the cathode and anode. Similar way in physics, if you use your ammeter and you find that the ammeter is coming down below 0, it is coming beneath 0. What does it mean? That you have connected ulto terminal. You have to change the terminals. The positive has to go to negative, negative has to come to positive. That you do in a physics also. You did in physics also. Right? Similarly here also, if your E cell comes in negative, then what you have done? Your terminals are opposite. Your readings are coming inappropriate, your terminals are opposite. Please change the cathode and anode. Clear? This way also you can do. But this is not a preferred way, because the preferred way is SRP series. It is EC series, electrochemical series. Clear? So this is just short tricks to manage the exam. Out of stage, anything can happen. So please make sure that it does not happen. Okay. So I am writing over here. If E0 cell comes negative, then যদি E0 cell negative হয়ে যায়, then interchange cathode and anode. Okay. Clear? So if E0 cell comes negative, please interchange the cathode and anode. No problem. Please interchange the cathode and the anode. Clear? Clear? Any more doubts over here? I think no doubts. No doubts. Okay, I cannot do many examples because I have to do the next parts also. So I think you have understood from this example that what you have to do. Clear? So one more application I'll just tell you of here. This is very important, that down the group down the AC series, SRP increases. As SRP increases, reducing power increases. Now you tell me, if reducing power increases, then the metals at the bottom will be found in the ionic state or free state. Answer is free state. Free state, not ionic state, because it is from the metals. That is why it is very hard to find sodium in nature in its free state. You will always find it in the form of ionic state. You will find it in the form of Na plus, but never in the form of N. Like you will, but it's very rare, very rare. Why? Because it is having a very low SRP, very negative SRP. It is an oxidizing agent. It is having oxidizing power. So it cannot be found in Na state easily. It will always exist Na plus only. Na will lose an electron to form Na plus. Clear? So remember, this is our application of AC series. So questions can be asked. We can find ores of copper. We can find we can find copper in free state, but we cannot find sodium in free state. Why? The answer is due to EC series SRP increases down the group. In EC series SRP increases down the EC series, due to which the metals at the bottom are found in free state, while that at the top are found in combined state, because the oxidizing power decreases. Clear? The reducing power increases. Understood? These are all applications of the EC series only. If you read the EC series and their applications in the book, it is clearly given, then you can easily understand. Okay? Clear? One confusion that you might face, probably due to me, is because I term reducing power as something else which is not normally understood, because I remember it in a different way and I have told that way only. So to make things a little bit simpler to you, see, what I told is that the metals which are located at the bottom, they will undergo reduction. So that they can stay in their metallic form. So I remember it as that as you go down the group, reducing power increases. But if you go by the conventions of IUPAC, if I go by the conventions of the books that are being published all around, then they term it as oxidizing power will increase, and that is the legitimate view of IUPAC also. Okay, we term it as oxidizing power. Why? Because itself it undergoes oxidation, itself is undergoes reduction, oxidizing the other person. So that is why we tell it as oxidizing power increases. Okay, clear? So you need not undergo such confusions. So I am changing it to oxidation only, because it is given in your book also. I think it is given as oxidation only. So just to avoid all sort of confusions, I am telling you. But I have explained to you why it is so, right? Simply remember that as you go down, the metals will try to be in their free state. So the tendency to undergo reduction increases. Simply is the tendency to undergo reduction increases. Basically, when I speak about reducing power, no, it is talking about how much it can reduce the other person, not itself. That is why there is some amount of confusion. But I remember it is reducing power only, because I might mess up, that's why. Simply. Now it depends on you how will you remember. In bookish language, if you go, or by the IUPAC convention, if you go, it is oxidizing power increases down the EC series. Clear? Now it is up to you how you remember. Okay? Clear? So please remember that oxidizing power increases means the tendency to oxidize the other person increases, not itself. Itself it cannot go undergo oxidation. So it will undergo reduction and it will oxidize someone else. So oxidizing power increases. Clear? So it will start behaving as what? It will start behaving as cathode. Okay? Clear? And those are at the top, they will be the anode. Clear? Yes, tell me. Clear? Those who are at the top will be the anode. Those who are at the bottom will behave as the cathode. Clear? Okay. Next topic we are going to read is basically a very important portion of this chapter, and question will be here. From this part, questions are going to come definitely, 101% chance. Okay. So that is Nernst equation. Here I will not explain anything, just the formula and application. Simple. What is the equation of Nernst? Acha, one thing I did not say, I forgot to say before going to the next equation, let me tell you. Okay, suppose here instead of this thing, that is the SRP value is not given. Instead of SRP value, what is given is SOP value is given. What I mean to say is the format as told by the IUPAC is E0 Mn plus M. If this is given, this is correct. This should be given in the question. But by chance, if the question says this, then what will you do? If the question is given this, then this is not the accepted value. So this I will have to first change to this. So always remember that this is just equal to minus times of Emn plus M. Clear? This is one of the important equation which you will use. Okay. That means if SOP is given, this is SOP, oxidation potential, and this is SRP. So if SOP is given, then we will write minus this SOP. Clear? So minus SOP will give you reduction potential. Similarly, if reduction potential is given and you want to go to oxidation potential, then you need not do that. If you want to go by some chance, then simply add a minus. Okay? Clear? Now let us move on to Nernst equation. Nernst equation states that at any other temperature, how to find out the cell potential. How to find out the cell potential at any other temperature than the standard conditions. Because standard conditions we know, but always achieving the standard condition is not possible for us. So at any other temperature, how can we find out the cell potential is given by Nernst equation. So the equation E cell, this is basically the cell potential at any temperature that will be given. Okay, E cell equal to E0 cell minus. So E cell will not be equal to E0 cell, right? It will not be. That is the condition. At any other temperature than standard, the cell potential will always be less than that of the standard potential, because it was the ideal condition. But here it is not the ideal condition. Okay, minus RT by NF times of ln, that is ln value, ln product, concentration of product upon concentration of reactant, same way. Clear? So this value is inside the ls, ln. Clear? Or rather I can write it as ln. Okay. Clear? So what is the Nernst equation? If you remember the Nernst equation, E cell equals to E0 cell minus RT by NF ln product upon reactant. So if I take up this ln to log, and if I put the values of R, put the values of T, and put the value of F, and put the value of F, then what will I get? I will get the some value. This T is basically my temperature of standard potential. This is T to 98 Kelvin. So if I put to T to 98 Kelvin, R some values, and F 96,500 coulomb, that is 1 Faraday. So that values if I put, then I will get some value, and that value only I will use, because every time it is not possible for me to put these values. Clear? So I will simplify my thing. So simplified version of this E0 cell, which you will use in the question also. Okay, you need not write this in the question. When you use this, you will write this second equation. Okay, this second equation is supposed to be written. So E cell equal to E0 cell minus 0.059 by n into log product upon reactor. But please make sure that you don't write it as ln. It is log. Okay, because 2.303 we have already multiplied, so that will become log base 10. Okay. When you are writing for the second case, then it is no more ln, it is log, simply log. Clear? So you are going to use this equation, because it is not always possible for you to find out the calculated value. So it is 0.059 by n log product by log product by n. Clear? This is how you are going to calculate the simple numericals will be presented. Very, very simple numericals. You already know how to find out, write the product of the, how to write the concentration of the product, and how to write the concentration of the reactant. So nothing new for you. Clear? No doubt. Next, relation of this E cell with equilibrium constant Kc. Remember, first thing I'm talking about, at equilibrium. A little bit of class 9 also I will drag, okay? Sorry, not class 9, my bad. I'm talking about class 9. I was teaching class 9, that's why. Okay, at equilibrium, delta G becomes 0, right? You have learnt in this in class 11. At equilibrium, delta G becomes 0. If it is a feasible reaction, then delta G must be less than 0. It is negative. If it is a like problematic reaction, then delta G must be greater than 0. Okay? Achha. That is not required. If it is wrong, if it is forgotten, maybe I also have said the wrong thing. Maybe I have forgotten. That's fine. Leave it. No problem. We don't need that. We are not doing thermodynamics over here. Okay. So delta G equal to 0. So delta G equal to 0, then E cell will also become 0. Okay. Please do not write E0 cell will become 0. Yeah. 0 minus something is negative. So please use your common sense and do not write E0 cell is 0. Okay. E0 cell cannot be 0. Or standard potential cannot be 0. In that case, E cell will become negative. That is not possible. So at standard conditions, E cell becomes 0. E0 cell, whatever it was, will remain. Clear? So at equilibrium, delta G will have to become 0. After E cell equal to 0, you can also write this as delta G 0 becomes 0. Can I write that? No. Because I cannot write that. Okay. Clear? So at equilibrium, delta G also becomes 0. E cell also becomes 0. No issues? Clear? So at equilibrium, delta G is equal to 0 and E cell will be also equal to 0. And at equilibrium, if you remember, it is Kc, right? We can define Kc only at which time? We can only define Kc at the time of equilibrium. Other than equilibrium, we used to define it by using a term called reaction coefficient. It is Qc, right? Reaction coefficient. It is called Qc or quality coefficient, whatever you say it is. It is Qc. So that Qc is defined at any other temperature than the equilibrium. Also at equilibrium, Qc becomes Kc, right? If delta G becomes less than 0, reaction is okay. If it is greater than 0, it will become a non-feasible reaction. It is non-spontaneous reaction. These are all you have done in class 11, right? Okay, anyway, that we are not coming to now. So as we have written the E cell equal to 0, so equation we wrote was E cell equal to E0 cell minus 0.059 by n log of Qc. Can I write it as Qc? Because I have told you that at any other temperature, if I am defining this, I can call it as a Qc. That is quality coefficient or reaction coefficient. Okay, it is same thing. Just the way you find out Kc. Okay, same way. So this I can write. This is 0, and this becomes E0 cell minus 0.059 upon n. This log Qc becomes log Kc. Clear? So this is my relation between E0 cell and my coefficient, equilibrium coefficient or equilibrium constant. Clear? So if it is asked what is the relation between equilibrium constant and E0 cell and standard electrode potential, then this will be my value. Clear? So generally question is given and from there you have to find out the equilibrium constant using this formula. Clear? So this is relation is very important. Please remember this relation. If you cannot remember, find out for me. No problem. So E0 cell equal to 0.059 by n log Kc. Done. Another relation I am giving. These are all the relations that you have to remember. Relation between Gibbs free energy, relation between Gibbs free energy and this electrode potential, standard electrode potential. If it is standard, then standard. If it is normal, then normal. So relation between Gibbs free energy and electrode potential. Relation between Gibbs free energy and electrode potential. Okay. So basically the relation you need to remember is delta Z0 equal to minus NF E0 cell. Okay, minus sign has to be there, very important. What is F? F is basically 96,500 coulomb. 96,500 coulomb. What is G? G is Gibbs free energy. Don't take free energy from him, we will slap you. So it is standard gives free energy because it is a 0 given top, so this is standard gives free energy. So similar equation I can write without the 0 also. So delta G equal to minus NFE cell. At that time it will not give a standard cell over here also. Okay. If nitrogen fiber to put n is the number of electron change that is always supposed to be put. Most important thing is here is that you have to put the minus sign. If you miss out the minus sign by some chance, there will be a big trouble from your head. Because the minus sign you cannot miss. Otherwise the answer will come, whenever it is supposed to come positive, it will come negative. Whenever it is supposed to come negative, it will come positive. So please make sure you don't miss out the negative sign. Okay? Clear? Clear? Any doubt you have? No. Achha. Now suppose I am finding out the delta G and log Kc's relation. That means Kc and Gibbs energy relation. That means equilibrium constant and Gibbs energy relation. And how will you find it out? See, E cell value we know na? E cell value we know. Previously only we calculated. E cell value is this one. So just put the E cell value. Simple. So how to put the E cell value? Just put it. Delta G0 equal to minus NF. E0 is cell's value is E0 cell's value is 0.059 upon n times of log Kc. Right? So n will get cancelled out minus this side. Clear? Just find out. It's easy. Okay. This time better is you don't put the 0.059, otherwise that f will again remain. So you can cancel out the net, but if you write 2.303 RT, then really they don't give you this question. If they give you, you just put the value of f. It is 0.059. Done. Simple. Clear? So it is, the relation is 0.059 f upon into log Kc. Please remember there is a minus sign over here. This is where you miss out minus values. The minus values you miss out. Now if you want to write that 0.05 minus 2.303 RT by NF, then N and F both will get cancelled out. So it will become minus 2.303 RT log Kc. But one problem you all make is that the value of T is 298 Kelvin, not a given temperature. It is 298 Kelvin. Okay. So make sure that you will know that T is given as 298 Kelvin, not as any other value. Because many of you will write that T has given something. It is given 300, we will let 300, but no. T is 298 Kelvin. Now other values should be written there. Okay, these are the relations that you have to read and you have to know. This is most least used relation is this one. Maximum used relation is delta G0 equal to this and Nernst equation. The maximum use of Nernst equation, that is this equation. Maximum use I am saying. Nernst equation, maximum use. Definitely one numerical will be coming in the 3-marker question from Nernst equation. So please make sure you can do it. Okay. Next we are coming to a very easy part. So now we can go low. The main part of the chapter is done. Now we are coming to a very low part of the chapter, or mostly a theoretical based chapter now. Now we are moving on to the theory of this chapter. Okay, tell me, who is an electrolyte, who is a non-electrolyte, who is a conductor, who is an insulator? Do I need to tell you that? No. You all know what is a conductor. If there are free ions present, then there will be flow of current, then it is a conductor. If there are no free ions present, it is insulator. Right? Electrolyte is also the same thing. If there are free substances, it will conduct electricity as electrolyte in molten state. If it is not that, it is not electrolyte. So that I need to know. But what I need to know from here is metallic conduction and electrolytic conduction. The difference between metallic conduction and electrolytic conduction, very important. This question might be asked. Conductor, insulator, they will not ask you definition. They will never ask you definition because they know that you are not class 9 kids. But what is the difference between metallic conduction and electrolytic conduction? This difference many of you don't know. So this question can be asked. Metallic conduction and electrolytic conduction. What is the difference between metallic conduction and electrolytic conduction? Do you know what is the difference between electrolytic conduction and metallic conduction? First definition. Achha, suppose you have your wires in your house. Do you have your wires in your house? Right. Achha, you tell me current is flowing through the house wires, through the, not the house. Right? Then you would have died. So current is flowing through the wires. Okay. Is there material changing? Is the material of the wire changing? No. If it is a copper wire, then copper wire only. If it is a aluminum wire, then aluminum wire only. Achha. So current is flowing. Conduction is happening, but no changes are happening. Changes means no chemical changes are happening. Conduction is happening, but no chemical change is happening. Right? So first and the foremost point of metallic conduction is no chemical change is happening. Very very important point. No chemical change. What is the first point? No chemical change. What is the electrolytic conductor? Chemical change. Simple, right? Chemical change observed. Clear? And this is electrolytic conductor, then chemical change will be observed due to decomposition of the electrolyte. Clear? So no chemical change in case of metallic conductor, but in case of electrolytic conductor there will be a change in it. Clear? 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 Clear. Now suppose you know that delta H, leave it not required. You know that if it is a metal, then resistance will increase if temperature is increased. This much physics I think I also know, that if temperature is increased, resistance will also increase for metals. So resistance increases, current decreases, right? So if I increase the temperature, then current will also decrease, start decreasing. So flow will decrease, right? So conduction will decrease if I increase the temperature, right or wrong? If I decrease the temperature, if I decrease temperature, then resistance has to decrease. So current has to increase, right? But I am increasing the temperature, that means resistance is also increasing, that means current will decrease, right? So what will I say? That metallic conduction decreases. Metallic conduction decreases with increase in temperature, correct? As I increase the temperature, metallic conduction will decrease. Temperature will increase, metallic conduction will decrease because resistance increases. Done. But electrolytic conductor is better because if I increase the temperature, the ions will be formed more easily. The breakdown will happen more easily. So this will become increases with increases in temperature. Clear? So increases with increase. Okay. First is decreases will increase, and if it is electrolytic conduction, then it will increase. Because if I give more temperature, ions will be broken down more easily. Simple. Okay. In metallic conduction, who is getting transferred? Who is getting transferred? Metals. Who is getting transferred? Free electrons. So movement of electrons. Right. So if it is a metallic conduction, then the conduction is happening due to movement of electrons. If it is electrolytic conduction, then movement of ions. Right. Electrolyte, no electrons will be present. It is movement of ions. So similarly, in case of metallic conduction, as electrons are movement, so I will not call it as a matter. So it is transfer of matter. Transfer of matter? No, it is not a transfer of matter. So transfer of, not लिखते हुए, so let us just get it. This highlight is not happening now. Sorry, not happening. I don't know why. So not transfer of matter. Clear? So no transfer of matter over here, and here transfer of matter because ions are being transferred. That is a good piece of matter, right? Because it has a good weight. So transfer of matter. So these are the four very important points that you need to remember between metallic conduction and electrolytic conduction. As I am repeating again, the first and the foremost point between metallic conduction and electrolytic conduction is electrolytic conduction will have some new chemical products and chemical composition will be altered. That means a chemical change will take place. But if it is a metallic conduction, no such thing happens because the wire which we are using remains that particular wire only with no change in that. Clear? Acha. Next. Metallic conductors will be showing a decrease in conduction if I increase temperature because of increase in the resistance of the wire. But for electrolytic conductors, it is electrolytic conduction. If I increase temperature, then the ions will be formed more easily, so it will have a good, better conduction. Next, if it is a metal, then it has free electrons, so conduction will be due to movement of free electrons. If it is electrolyte, then conduction will be due to movement of ions, right? Next, as electrons are not considered to be matter, then movement will be not due to matter. So no transfer of matter. Done. On the other hand, there will be transfer of matter in the form of ions in case of electrolytic conductor. Simple. Clear? This difference between both of them are very important for you all to remember. Tell me, clear? Okay. Next, some basic terms which I even don't need to just say because you all know all these terms. First is Mr. Resistance. Who? Resistance. So what is resistance? Do I need to say that? Resistance is R. Okay, please read. Resistance is the resistance, it is the obstruction given to the flow of current by the conductor. The obstruction given to the flow of current is called resistance. So please read, you know the resistance already. Resistance is given as voltage upon current, right? Voltage upon current. How much ever voltage divided by current. Clear? Okay. So this is founded from which law? This is founded from Ohm's law. So I hope Ohm's law you already know. Let's go ahead with that. Okay. Next, resistance we have learned. The resistance we have learned. Another resistance is there. It's called a specific resistance. That is called specific resistance. Specific resistance. This is normal resistance that we will define for a particular substance, but it's called specific resistance, also called as resistivity. All VTs are specific. Conductivity is also specific, resistivity is also specific. So specific resistance is given as rho. It is given by rho. So rho equal to 1 by R. 1 by R. Wrong. This is not the inverse. Okay. Please do not take it as that. Okay. So it is rho and it is given as R equal to rho L upon A. Okay. R equal to rho L upon A. It is found that resistance depends on the length and on the area, but inversely. So L by A. Constant is specific resistance. Clear? Also called as resistivity. Okay, tell me, clear? So what is going to be my unit? Unit of resistance. So in chemistry, from this portion, units are very important. So please, what is the unit of resistance? Ohm. Already known. What is the unit of resistivity? You can calculate it. Find out. Resistance will be equal to 1 by R into L upon A. This is basically what? 1 by ohm. This is basically what? Meter. This is what? Meter square. So ohm per meter. Or if we take it in centimeter, meter will be a very big unit for this because we don't take meters. So it is centimeter. So ohm centimeter. The determinant concentration will come in format of centimeter only. So unit will be ohm inverse centimeter inverse. Clear? Then ohm inverse centimeter inverse. Clear? 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 And I will come out of the laptop, sorry, my screen I mean, and I'll give you one tight beating. And you're saying yes, I can see you're saying yes. How? I am saying clear, you're saying yes. Then you will find in the exam you're getting 0, you are not understand why you're getting 0. I did something, you said yes, okay, that's correct, correct? Use your brain also sometimes. I wrote what? R equal to rho L by A. And you are saying okay, fine, correct, fine. Next step I wrote rho equal to 1 by R into L by A. Okay, fine. What fine? This is fine. Use your brain sometimes. You don't use your brain at all. They are saying yes. So this is 1 by R into L by A. How it is 1 by R? Wait, 1 by R ta kothay gelo? It's coming from heaven or what? How it is coming 1 by R? Like that randomly it will come 1 by R. So rho is there, it will become A by L. To become A by L. So the unit will not have any inverse. It will be ohm centimeter only. This inverse will not be there. Clear? Are bhaiya, please go away. This will be ohm centimeter. Please use your brain a little bit. Okay. So the unit will be ohm centimeter. Clear? Any doubt? No doubt, no more. Please do not try to do because I will do this type of things only. In my video, I often do this intentionally. Okay, next. Specific resistance clear? Resistance clear? Resistance, then comes specific resistance. We found resistance dependent on length and area. Clear? So dependent on that, we have find out a new term is specific resistance. Now the inverse of the resistance is called as conductance. So please do not get confused between conductance and specific resistance. Specific resistance is not inverse. That is the first mistake you will do. That also I have done intentionally to show you. Second mistake also you will do is in this case. 1 by R you will write. That I used to do a lot. Not now. I used to do a lot. and I showed it now because I remember all my mistakes. Conductance represented by C will be equal to 1 upon R. Simply, so what is going to be my unit? As my unit is going to be, this time it is going to be my ohm inverse, also called as ohm inverse, also called as MHO. What is this called as? MHO. MHO. Okay, also called as Siemens. Okay, Siemens. Siemens. We write it as S. Okay, Siemens. 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 Okay, you can call this Simon, whatever you want to write. That is your dependent on you. Whatever you want to say, you say. I don't mind. Okay, next. If resistance has an inverse, then resistivity also must have inverse. So that resistance will be called as conductivity. Conductivity or specific resistance. Sorry, specific conductance, not resistance. Specific conductance. Clear? Because specific conductivity or specific conductance. This is represented by sigma. Sigma only I think. Sigma or kappa. Generally we use kappa. Okay. Sigma or kappa. What is the formula? Formula is basically kappa equal to 1 upon rho. Simply 1 upon rho. So if I write the formula kappa equal to 1 upon rho, what is the formula of rho? R equal to rho L by A. So rho equal to R into A by L, right? R into A by L. Rho equal to R into A by L. So can I write that as 1 by R into L upon A, right? Because it will be ulta. It should be 1 by A. So L by A will become top, right? So this is going to be my kappa's formula, right? So from here I can write modification formula kappa equal to, this is C. Just now we have done. This is conductance. 1 by R is conductance and L by R will be called as L by R A only. So this is my final formula, and this value L by A is called as cell constant, which is usually given in the question. Okay, this value is called, for a cell, this L by A value will always be a constant. This will be called as cell constant. C will be called as my conductance that you just now found out in the last one. Now tell me, clear? So whenever you are going to find out the value of kappa using this data, given the question whatever data, according to this data we use this one. Clear, clear, clear. Please, clear. Okay, this unit will be known as ohm inverse, centimeter inverse. So let's calculate this unit. See, ohm inverse and centimeter inverse. So this is one mistake which you make. This is the unit of this kappa will be called as, so kappa unit is ohm inverse, centimeter inverse. Okay, so this unit we found out there for resistivity, but that is wrong. Okay, resistivity ulta, so kappa will become ohm inverse, centimeter inverse, and that will become ohm centimeter. Okay, done. Kappa clear? Understood kappa? Okay, next terminologies are important because we will go with this terminologies. We will go for Colorau's law. Using this terminology, we will go for Colorau's law. Later on, we will find out Colorau's law. Colorau's law is very easy to remember also. But two terminologies there is no. One is no. Definitions are not required. But adjacent reasoning definitions can be given. So that's why I'm telling you the definition, but I'm not writing it because it's not for you to memorize the definitions. But that definitions can be asked. Yeah. Okay. It's 1 hour 23 minutes already recording. Okay, electrolytic conductivity. First is electrolytic molar conductivity. Electrolytic lekha dorkar nahi, barbar na it will take too much time. First one is molar conductivity. Oof, baba, this will never be shanti, I think. First one is molar conductivity. Molar conductivity. And second term is equivalent conductivity. Two terms I'm telling you simultaneously, will find it's very easy to understand. Just you have to understand the concept, then you have to interpret it from the given question. See, molar conductivity is represented by lambda m and equivalent conductivity is represented by lambda n. Clear? Simply lambda m and lambda n. Okay, lambda m and lambda n. Molar conductivity is the conducting power of all the ions furnished by a solution of 1 mole. Clear? So 1 molar solution যতগুলো আয়ন প্রডিউস করবে their conducting power will be called as equivalent conductivity. Understood? Sorry, molar conductivity, not equivalent. Equivalent, na full. Sorry. So the amount of the total conducting power of all the ions furnished by a solution of 1 molar is called as, in a given volume of 1 molar solution will be called as uh, molar conductivity, and if it is 1 gram equivalent, then it is equivalent conductivity. Clear? So this will be by 1 mole and this will be by 1 gram equivalent. Okay, simply just remember that molar conductivity or molar conductance or equivalent conductance, whatever it is given, same thing. Please remember it is 1 mole of electrolyte done, and this is 1 gram equivalent electrolyte. This can be replaced by the term conductance as well. So do not get tense at what is molar conductance. You have not read. No, it's fine. Same thing. Okay. So 1 mole electrolyte, 1 mole electrolyte furnishes how many ions? This is molar conductivity. 1 gram electrolyte, 1 gram equivalent electrolyte furnishes how many ions? That is how many ions of conducting power? Then it will be called as equivalent conductivity. Okay, let me clear. Formula for both the cases remain the same. Formula for both the cases remain the same. I think one time only. Kappa equal to lambda m equal to kappa into 1000 upon m, and lambda n equal to kappa into clear? Lambda m equal to kappa into 1000 by m. If it is lambda n, then n by m. Okay, remember the concentration is always given in the form of mole per liter. Okay, then we will use this equation. Then we clear? Any doubt you are having? Any doubt you are having? Doubt? Any doubt? No doubt. Very good. Next page, please. Relation between this and this is very important relation. So please make sure that you remember the relation. See, relation is very easy. If you forget, it is not a big problem. See, lambda m by lambda n. Okay, lambda m by lambda, if I do the ratio, then kappa will get cancelled. 1000 by m and 1000 by n will come. So it will come n by m. Right? If it is n by m, if it is m by n, it will come n by m. Right? Because it's 1000 by n, right? So n will come go and n will go up. So n by m. Acha. N if I expand, then you tell me it is basically number of gram equivalent. Volume will be same. Definite volume. Volume will also get cancelled out. So number of gram equivalent divided by equivalent mass. Right? How to find out this? And molar mass is molar mass divided by number of moles. Right? So basically this number of mole, how will you calculate? Sorry. Wrong. Very my bad. If I am writing, this is wrong. This statement was wrong. Sorry. Number of this will be number of gram equivalent per unit volume into volume divided by number of moles. Now it is okay. I wrote the wrong thing. Volume cancel out. Clear? So number of gram equivalent divided by volume into volume by number of moles. Done. Now expand this number of gram equivalent. So this will be mass divided by equivalent mass, and this will be molar mass divided by mass. Mass cancel out. So I am having molar mass by equivalent mass. Clear? Into lambda m. This will be my lambda. Okay. A little bit simplification if you want to do, simply remember delta m equal to n factor into delta n. This is analogous to that equation which you use in SBCOC class 11, that is normality equal to molarity into n factor. In class 11 you use this equation. Normality, to find out normality you will multiply molarity with the n factor, but here it is opposite. if you remember this also you can find out that is opposite of this. That means molarity সাথে molarity বার করতে গেলে নরমালি ইনটু n ফ্যাক্টর করতে হবে। ইন কেস অফ ইলেকট্রোকেমিস্ট্রি নরমাল করতে গেলে এটা করতে হবে, ঠিক আছে? You don't know the formula, no problem, find out the formula, ঠিক আছে? So equivalent conductivity into n factor will give me the molar conductivity of the solution. Any doubt till now? Let me drink some water. Let's come back. Units. Units of this and units of this. Let's calculate quickly the unit of this. Lambda m. What is the formula? Kappa into 1000 upon molarity, right? Okay. What was the unit of kappa we found out? Just some time before. Ohm inverse centimeter inverse, right? The unit of kappa was ohm inverse centimeter inverse, right? Into molarity unit will be mole upon liter, but this is inverse, so this will become liter, but liter will not come because 1000 I have told, so this will become centimeter cube divided by liter. Liter. Oof. Centimeter cube upon mole, right? Because I am taking it as 1000, so that value has been converted to centimeter cube. Clear? So centimeter cube and mole, right? So what is going to be my unit? Ohm inverse, mole inverse, centimeter square. Okay. I know it is a little bit difficult to remember it. It is your choice. You can remember it or not. How will you remember? It is your choice. You can find it out in exam. No problem with that. Okay. Similarly, if I want to find out n, then what will happen? Same unit. Same unit. What will just change? Instead of this, it will become centimeter square. It will become equivalent inverse. Clear? Because mole will not come, equivalent will come. But centimeter cube will come. So instead of mole inverse, it will become equivalent inverse. Done. This unit you have to remember. These are the units of these two rates. Okay. Next we will go to, this is done. Next we will go to the important part, a little bit important part, this Kohlrausch's law, the second last part of this chapter. After that you have electrolysis only and the chapter will be done. Okay, major part of the chapter. After that there is a theoretical part of the chapter that is called the battery part. It will not take a lot of time. Battery part. Okay. First important point to note over here. See, molar conductivity decreases. Okay, molar conductivity decreases with increase in concentration. Please remember this, that if I increase the concentration for both strong and weak electrolyte, the delta M, that is value of molar conductivity, will decrease, but the decrease is not uniform for both the cases. Okay, the graph is very important. If it is a strong electrolyte, then the graph will go almost like this. That is, very slowly it will decrease. The graph, it will decrease very slowly. Okay, the graph is versus delta M versus root over C. Its concentration 0. Now you see, if I am extending the graph behind, that is 0, root C is 0, then I am getting one value, right? This value. Then this value will be called as delta M infinity, right? That means when delta C becomes 0, the value that we are getting is the value at infinite dilution. Okay, so this is, remember this value is very important. It is molar conductivity at infinite dilution. Okay, molar conductivity at infinite dilution, where root C becomes 0. Where root C becomes 0, C will tend to infinity. Clear? Clear? C tends to 0, root C tends to 0. Done. So molar conductivity at infinite dilution. That is this point. When we are extending this line behind to the point, then we are getting a value, that is the delta M, that is the delta M infinity. Clear? So the graph of strong, this is the graph of strong electrolyte. So if it is a strong electrolyte, then graph will go like this. Okay. Clear? If it is a weak electrolyte, then the graph will go like this. Weak electrolyte. So you have to identify that from the graph. This is the graph of a weak electrolyte. So this is the graph of weak electrolyte. So this graph can be given in the question, and question can ask you, which tell me what happened in this. What graph? Whose graph is this? So can I get any point where delta C will become 0? Can I get any point where delta C will become 0? So delta M infinity for strong electrolyte I can easily find from the graph only. I can find it out. If I take some points at some concentration, I can draw the graph, then I can easily find it out. No problem for that. But for this weak electrolyte, can I find out the value of delta M infinity? The answer is no. Because I am never getting a point on the graph I cannot touch this graph with this axis only to get a point. So how will I find it out? There comes a new rule. It is called Kohlrausch's law. What law? Acha, before that one more, just I will tell one equation, not a big equation. Delta m is related to delta m infinity as this equation, minus b root c. Okay, this equation is called d by Haeckel-Onsager equation. D by Haeckel-Onsager equation. D by you have read somewhere. Try to recall. D by Haeckel-Onsager equation. Onsager equation. Okay. Using this equation, if you put this value 0, then this entire value becomes 0, then this will become equal to this. Clear? So b root c must be 0 only when in this condition. Clear? When root c tends to 0, delta become delta m infinity. Simple equation, no difficulty. Okay. Next. Okay, done. This is clear to you. Any more doubts? No doubts? Very good. Next, let us move on to Kohlrausch's law. Kohlrausch's law. Kohlrausch's law. The spelling is a dangerous spelling. Kohlrausch's law. I am not telling you the law right now because the more important now is for you to memorize the understand the concept. Okay, please read the law. Read. Okay, read the law from the book. You will find that Kohlrausch's law states that the molar conductivity at infinite dilution of an electrolyte will be equal to the molar conductivity of sum of the ions comprising the electrolyte. Simple. Okay, sum of the ions comprising the electrolyte. I will explain this with the help of an example. Okay, suppose I have got NaCl. Okay, then how can I find out delta m infinite? Delta infinite of NaCl, how will I able to find out? I cannot find out using the graph because that will give me weak electrolyte. This is a weak electrolyte, so the graph will come in the form of a straight line. Not straight line will come, no, it will come in the form of parabola type of hyperbola type of thing. I forgot that anyway. Okay, so this I can use by Kohlrausch's law. So that will become delta infinity Na plus and delta infinity Cl minus. Understood? So molar conductivity of the entire electrolyte will be equal to the molar conductivity of the comprising ion. Simple thing. Next, if it is BaCl2, then you have to multiply the value. Please do not forget that. Ba2 plus, this will write plus 2 times delta Cl minus. Don't forget this 2. Multiply this 2 always. Clear? So this is the way to find out. One simple question I will give you from here, with the help of which you can understand. The question that comes in the exam will not be given in this question. Might be given in this question in MCQ, might come. The question is, in the question it is given BaOH2. Molar conductivity is given. Then what is given? BaCl2 molar conductivity is given. And NH4Cl molar conductivity is given. Okay. Question will be asking you, find out the molar conductivity of NH4OH. This will be the question. Then find out the molar conductivity of NH4OH. I think it is asked that only. Find out the molar conductivity of NH4OH. Right? Question will be asking you that you find out the molar conductivity of NH4OH if all these data are given in the question. 523.28. Then this is given as 280.0 and given as 129.8. Achha, 129.8. Units are ohm inverse, centimeter square, mole inverse. Right? Same units for all. Copy it. I am not writing every time. Ohm inverse. Then now you have to find it. How will you find out that? First and the foremost thing you will do is you will break down everything into ions format. I have to find out NH4OH. So which ions I need? I need only NH4 plus and 1 OH minus ion. So I will need NH4 plus and 1 OH minus ion. First of all, let me break down that thing. Okay. Barium will release barium 2 plus 2 times OH minus, right? Plus barium chloride will again release barium 2 plus 2 times Cl minus. Right? See, I am just writing the given data in the form of their respective ions. Ba2 plus লিখলাম, OH minus লিখলাম কতগুলো? দুটো, barium 2 plus একটা, কটা chlorine? দুটো chlorine. Done. Plus NH4 plus, so delta plus Cl, right? So this is going to be my only 1 Cl. Done. Then this is the required ion test to be found. Okay. So which ion I need? I need this ion and I need this ion. But you can see that this is twice in number. এটা দুখানা আছে আর এটা একখানা আছে. But one molecule combines with only one. So by force I have to multiply this with 2. By my force I have to multiply this with 2. Why? Because otherwise my fitting will not happen. Okay, so I have to multiply this entire thing because NH4 2 plus 2 to multiply kori, the entire compound will get multiplied by 2. Please do not make that mistake. Okay, so this entire substance will be multiplied by 2. Why I will multiply it by 2? Because I have to make twice NH4. Because 2 of these are here, so this has to be 2. Otherwise also one thing you can do is you can divide this entire thing by 2, but that will not do. That will take a little bit more complex. Okay, so this is clear. So we will multiply both the things by 2. Then we are getting the value done. So I am writing it as delta Ba2 plus 2 lambda OH minus infinity plus lambda. I am shortening it up so that I don't need to write so much. No. Shortening will become complex. Ba2 plus 2 lambda Cl minus infinity plus 2 times NH4 plus 2 times Cl minus infinity. Then now I can answer my question. So my question was asking me that I have to find out NH4OH infinity. So how many times NH4OH I have got? 2 times I have got. So I will multiply at 2. Clear? Equal to barium hydroxide. Ja aage likhechilam first step e same step. So this will become BaOH whole 2. So same value I will put. So this will become delta barium hydroxide. Okay, done. Plus this was whatever in the question given, same thing I have put out. So this will also become my NH4Cl I did not need, it is NH4 only. So this will become, I am now writing this minus. Why minus? Because barium chloride I don't need, barium also I don't need, chlorine also I don't need. So this has to be subtracted. Clear? Please remember which subtracted, which addition. This barium chloride has to, this is only my rough work to understand where to have to multiply, where I have to multiply 3, 4, whatever. So this is rough work. Final I am writing here. As I can see that this is whatever the first step I wrote same. So I am writing this. Next, barium chloride, if chlorine is not required, barium is also not required. So barium chloride I am omitting from the question. So I am subtracting the given barium chloride's conductivity. Done. Plus I am multiplying, this is what? NH4Cl. How many NH4Cl I have taken? 2 times NH4Cl I have taken. See, 2 times NH4Cl I have taken. So it will become 2 times NH4Cl. Done. And you see that given data will satisfy the data. See, barium cut off, hydroxide 2 done, barium gone, chlorine 2 gone. So NH4OH done. So both sides will become now same. See, calculate this side will come same. 2Cl will go with this, NH4 twice, oxygen twice. Done. So both sides are equal. Now just what you need to do is put the value, throw it on the calculator and calculate. I don't think so that I need to do that much also. And divide the final answer by 2, please. Clear? Concept clear? Tell me. Concept clear, because one question from Kohlrausch's law is expected in the exam. Okay? Kohlrausch's law clear? Okay. Acha, video is getting too long. It is almost 1 hour 43 minutes. I will try to end it as soon as possible. Next comes Faraday's law. Faraday law's question is basically based on the first law only. Please read the laws on the book. Law 1, law 2. Two laws are there, okay? Law 1, law 2. Please read law 1 and law 2. Law 1 says that amount of amount of substance deposited at any electrode will be directly proportional to the quantity of electricity that we are passing into solution. Okay, what is law number 1? Law number 1 says that amount of matter that will be deposited, amount of substance deposited at an electrode will be directly proportional to the amount of electricity that is passing to the solution. Amount of current you are passing to the solution will directly affect that. Then second law on the other hand says that when the same quantity of electricity is now same. When the same quantity of electricity is passed to the solution of two different electrolytes but connected in series, then the amount of mass deposited will be in ratio of their equivalent weights. Okay, first law, I am repeating. First law states that the amount of matter or amount of substance deposited at any of the electrodes will be directly proportional to the current passing through the solution. Second law states that when the same amount of current is passed through two different electrolyte solutions connected in series, then the substances deposited will be in the ratio of their equivalent weights. Okay, so just you need to remember two three things I'm telling you from here. The first formula, M equal to ZIT. Okay, M equal to ZIT, when Z is called electrochemical equivalent. Z is called electrochemical equivalent. How will you find Z? Z equals to equivalent mass upon Faraday constant. Z equals to equivalent mass upon Faraday constant. Z equal to equivalent mass upon 96,500. Clear? Z is always equivalent mass upon 96,500. Z is given the question, very good. Otherwise, you have to find out first the equivalent mass of that substance. I hope you all know how to find it out. You have to find equivalent mass. How to find that equivalent mass? Equivalent mass equals to how? Molar mass upon n factor. If it is an iron, then ion's charge. If it's a metal, then valency, and all these are the n factor. Okay, so equivalent mass equal to molar mass upon n factor. Okay, this is the first formula, M equal to Z8. And second formula, according to the second formula, M1 by M2 will be equal to weight 1 by weight 2. Done. Two formulas. But two more things I will tell you. That I will tell you next page. And please note down, very very important, because this will help you in the MCQ solving. To deposit 1 gram equivalent of any substance. What am I saying? To deposit 1 gram equivalent any substance, 1 Faraday electricity required. 1 Faraday electricity required. Clear? To deposit 1 gram equivalent of any substance, the amount of current that you will require is 1 Faraday. The amount of current you will require is 1 Faraday. Any substance, not particular one. This copper I will tell you, no. For any substance, the amount of current you require to deposit 1 gram equivalent will be 1 Faraday. Done. Similarly, the second part, to deposit 1 mole of any substance will be equal to NF electricity. Rather, I should say NF coulomb required. NF coulomb required. So if I write you all will think it as coulomb concentration. That's why I am not writing it. Clear? So to deposit 1 mole, you need NF times of Faraday, and if it is 1 gram equivalent, then you require only 1 Faraday. Clear? Now tell me any doubt you have. The easy thing, right? Easy. It's a Faraday, and that is where the numerical generally asks. Clear? Now we have a very less part left, that is called the battery part. Okay. Now we are going to read about some primary cells, which is basically going to be about 3 types: primary cell and secondary cell. Under primary 2 types, under secondary 1 type, and 1 hydrogen oxygen fuel cell. That's all we'll read. First, let us discuss about primary cell. So you tell me, what is a primary cell? A primary cell is a cell which you use for only one time. That means it cannot be reused. One time you use and throw it. So it will have irreversible cell reaction. It cannot be reversed. So under this we are going to read only 2 types. Number 1, we will read it as Leclanche cell. And second one we will read it as, spelling might be a little bit wrong. So spelling, just take it out, okay. Under this, what you have to read? Cathode, anode, electrolyte and cell reaction. That's all you have to read from here. Okay. Cathode. Remember, Leclanche cell and Mercury cell, they are very similar to each other. more or less cathode and anode are also similar to each other. More or less, not all, but more or less cathode and anode are also similar to each other. So remember, for mercury cell it will be basically the mercury amalgam, and normal case it will be normal, and for Leclanche cell it is normal, so electrolyte. Okay, okay. For cathode it is, for cathode it will be graphite rod. Okay, cathode it will be graphite rod with charcoal, surrounded by charcoal and carbon. Charcoal is also carbon, so you can also write graphite rod surrounded by charcoal and carbon. Okay. Or you can also, better not to write charcoal. Charcoal will be next step, because graphite is also a form of carbon only. So better to highlight this MnO2. Okay, graphite rod surrounded with MnO2, and anode will be a zinc. Okay, anode will be zinc. Anode will be zinc metal, and graphite rod will be surrounded by MnO2, which will be this. NO2 also plus carbon लिखिए दो, charcoal लिखिए दो, charcoal is there, charcoal also mention. Graphite rod surrounded by MnO2 and charcoal, but or carbon. Anode made up of zinc. Electrolyte that we will be using in the solution will be NH4Cl and ZnCl2 mixture. Okay, this will be my electrolyte. Clear? Leclanche cell, you just need to remember these three things and the reaction. Nothing else you need to remember. All working diagram, no. Cathode, graphite rod, plus carbon, plus MnO2. Anode, zinc, electrolyte, ammonium chloride, zinc chloride. Done. Now come to the cell reaction. So you tell me, anode what will happen? Zinc can only change to zinc 2 plus, nothing else will happen. So zinc changes to 2 plus, so 2 electron. In the anode we had carbon. But carbon cannot react with anything like that to form CO2 to form. No. So reaction does not happen with carbon, but happens with the surrounding MnO2. Okay. Surrounding MnO2 reacts with the ammonium ion present to take up one electron. So what will happen, you tell me? This ammonia is having one extra H plus, and this H plus electron can take up. So this will form straightforward NH3. Okay. This will form ammonia, and another product formed is MnOOH. This is a different product, so remember this product. This will form NH3. Okay. Clear? Voltage of this is approximately 1.25 volt to 1.5 volt. Approximately 1.25 to 1.5 volt. The cell reaction to remember, and the overall reaction you can calculate by multiplying with the 2 and cancelling of the reaction. Clear? So again I am repeating: Leclanche cell, cathode graphite rod surrounded by MnO2 and carbon, anode zinc, electrolyte zinc chloride, ammonium chloride, reaction given over here. Clear? Next, this is completely theory based, I'm telling you. Number 2, mercury cell. Mercury cell, same, cathode, anode, electrolyte, cell reaction next is voltage. Voltage is 1.35 volt. Huh? Voltage will be 1.35 volt. Remember, voltage is 1.35 volt. Okay. Achha. Cathode, zinc mercury amalgam. This time it is zinc mercury amalgam. You can also write only zinc amalgam, because amalgam's definition is only mercury present. So you also can write only zinc amalgam also. Zinc mercury amalgam. Anode is this time carbon. Anode is this time carbon with HgO, or you can write HgO with carbon. Okay. Last time it was graphite in case of cathode along with MnO2 and carbon, and anode was zinc. This time cathode will be oh sorry, mention one thing. What am I saying? I think it is 3:30, that's why my brain is lagging a little bit. Okay, anyway, not a big deal. Same reaction, same thing as previous case. Previous case zinc was anode, so zinc mercury amalgam will be the anode. Zinc mercury amalgam will be the anode amalgam, and cathode will be HgO surrounded by carbon. Same case as previously. Previously what was there? For case of cathode, it was graphite surrounded by MnO2 and carbon. Here also cathode is same, but it is not graphite HgO. Anode previously was only zinc. Since it is a mercury cell, then zinc mercury amalgam. And the electrolyte that we will be using for this will be KOH plus ZnO. Okay, KOH plus ZnO. So this is a basic medium. Acha. Voltage is constant. Why? Constant voltage. This gives you a constant voltage because no ions are involved in cell reaction. Okay, in the cell reaction there are no ions. So if there are no ions in the cell reaction, then concentration is not changing. Okay, concentration does not change. So if concentration does not change, then there is no scope of any change. Clear? Concentration does not change, so voltage is constant. So what is the reaction? Zinc plus OH minus. Zinc will take up now OH minus side to form ZnO plus water plus 2 electron. So there must be 4 zinc. No, sorry, 4 zinc at now. The electron change, then there will be 2. Okay, 2 electron, so 2 OH plus ZnO plus water. Clear? The reaction is going to follow this. Zinc plus hydroxide ions will form zinc oxide, that is my electrolyte material, plus water plus 2 electrons. Okay, and on the other hand we have mercury oxide that will take up this 2 electron and that will take up the water also to form mercury, and this 2 hydroxide will not be there. When if you remember one equation, it will be done. Okay, so the next cell reaction will be Zn plus HgO forms ZnO plus H. Clear? So you can see that there are no ions, all these are fixed concentration. So there is no change. So there is no change, then what is the question coming up? Okay, next, secondary cell. Under secondary cell, we will need only one cell, that is called the lead storage battery, that we will use in the gadi battery. Okay, acha. Secondary cells are those cells which can be refilled, which can be reused, which can be reversible reactions occur and they can be reused again. So under secondary cell, we need only about lead storage battery. Lead storage battery, it is a car battery, lead storage. Okay, so their anode and cathode both are lead. Obviously both has to be lead, both will be used as lead. Electrolyte used, we will see, and we will see the cell reaction also. Okay, anode is also lead, cathode is also lead, but one case there is lead oxide and one case there is lead. Okay, see, anode is oxidizing electrode, so anode definitely will form Pb2 plus, so this is only lead and this will be PbO2. That means Pb plus PbO2, actual means Pb plus PbO2, reaction happens with only Pb and this is only Pb. Clear? So if I go for anode, then it will be lead dioxide, and if it is cathode, then only lead. Clear? 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 Okay, so cathode is having PbO2, means lead plus lead dioxide, and anode is having only lead. Electrolyte is Mr. Concentrated H2SO4. Clear? Anode is concentrated H2SO4. Sorry, not anode. The electrolyte. The electrolyte solution is concentrated H2SO4. Please remember that H2SO4 will be reformed and discharged again. Okay. Generally, the reactions for this is not asked, but two cases will come up over here. One is discharge and one is recharge. During discharging reaction, you will always remember during discharge PbSO4 formed. What do you remember? During discharging PbSO4 will be formed, and during recharging PbSO4 will be used up. Clear? Another question is used. So if PbSO4 is used, then formation will be sulfuric acid, lead and lead dioxide, right? So if you remember one side of equation, then the other side of equation is very easy to remember, because just opposite thing. Okay, so I am writing for discharge. Okay, for discharge. This one I am writing. For discharge, what I am writing, see, PB. This is for anode. Because anode was only lead. So anode plus. So anode plus. Sulfuric acid sulfate ions. So this will form ultimately what? Lead sulfate plus 2 electron. Okay. Lead sulfate plus 2 electron. On the other hand, this is the cathode reaction. Okay. This is the anode reaction. If I go for cathode reaction, then what will happen? Then lead oxide plus 4 hydrogen plus sulfate ion plus the 2 electrons. Okay, they will form again lead sulfate plus 2 water. Now during recharging, just opposite. Recharging, opposite. That means this will become my reactant, this will become my reactant, this side will become product, this side will become product. Clear? Same reaction, opposite side will let and it will become the recharging. So basically during the discharging, lead is consumed to form lead sulfate. These languages will be given in the MCQ to read. Lead is consumed, correct. Lead sulfate is consumed, no. Lead oxide is consumed, correct. So multiple choice might be correct, like they are giving you 4 options and they are saying A and B is correct, B and C is correct, like this. Clear? So reaction understood. Lead plus sulfate forms lead sulfate plus 2 electron. Lead oxide plus 4H plus SO4 plus 2 electron forms 2PbSO4 plus 2H2. This is the reaction that you have to read. Done. Okay. Clear? Next is hydrogen oxygen fuel cell. Remember, this is a eco-friendly mode, but this is costly. This is eco-friendly mode, but this is costly. Okay. Hydrogen oxygen fuel cell was used in Apollo. In Apollo, that is Apollo space program, USA. Apollo space program, Apollo 11 and all those things were there. So this hydrogen oxygen fuel cell was used to power up that Apollo mission as well. In hydrogen oxygen, you can understand one is the oxidizing and one is the reducing. So in this case, we use hydrogen at the anode because hydrogen is over oxygen or oxygen is below, oxygen is lower, hydrogen is above. Okay, so hydrogen will behave as the anode while oxygen will behave as the cathode. So remember, anode will be hydrogen, which is H2, cathode will be oxygen O2. Okay, so the reaction that takes place is, okay, before the reaction, the electrolyte I have not mentioned. Okay, I am writing that side only. Electrolyte used will be concentrated base. Electrolyte used will be a concentrated base. So usually it is concentrated NaOH or concentrated KOH also you can give. So concentrated NaOH is the base. Okay, concentrated NaOH is the base. So what is the reaction? H2 plus 2OH minus forms, okay, hydrogen plus 2 oxygen. So it will form a water plus 2 electron will be released. Okay. Similarly, other side, if you react it with this 2 water, oxygen will react with 2 water. Oxygen takes up 4 electron because each takes up 2. So this will form a 4 OH minus in aqueous state. Okay. This will cut off, multiplying 2 electron, 4 electron can be cut off. So the major reaction that takes place is 2 hydrogen plus oxygen forms water. So you already know it's 2 water liquid. So this is an eco-friendly mode because from here I am not getting any pollutants. But there are some limitations and there are some efficiency. So question might be asked based on efficiency and based on the demerits of this. Efficiency, you can see this is a high efficiency. It has a very high efficiency. Second, I can see it to be pollution free because products are all good. Then continuous supply, because this reaction takes place continuously. But what I have to do is, what are the limitations of this? That I have to put a continuous supply of this. So handling is becoming difficult because this is a gaseous fuel. Handling difficult, right? Because this is gaseous fuels and it's very difficult to handle, right? Catalyst required because since it is a gas, it needs a surface. So catalyst required, and that catalysts are basically the inert metals. That is gold. Catalyst required are gold, platinum, gold, silver, which are costly, right? These are costly and these are rare metals. So you have to use this properly. Okay. Then corrosive corrosive electrolyte. Concentrated NaOH is highly corrosive, so this is a corrosive electrolytic solution. So that causes a lot of problem. Okay. Next, you have a little bit of part that is called corrosion. Corrosion's idea is not at all difficult for you. So please read corrosion from your book. I think corrosion নিয়ে আমি কিছু বলতে হবে না, because you know what is corrosion. Corrosion is basically একটা metal surface কে যদি আমি এর দিকে expose করে রাখি, তাহলে environment এর সাথে interaction করে if it is going to degrade, if it is going to destroy the metal itself is going to be destroyed due to interaction with the outside environment will be called as corrosion. So as simple as that, corrosion niye eta discuss much. It's clear? So this is the entire chapter of electrochemistry that you have to read for your ISC exam. Okay. So let's meet again tomorrow. See, the time is 3:48 and I have not slept yet. Okay, anyway. So let's meet again in the next video. I hope you have understood the chapter electrochemistry. Okay. Bye bye.